5.3, graphing trigonometric functions. So we have all these values on the unit circle, and the points go cosine first, and then sine. What if we unrolled this and put it on a normal graph? So our first point, we always start down here. It's 1, 0. Sine is 0. So we're starting here. It gets bigger as we go out. Gets a little bit bigger. We're on this one. This one here, a little bit bigger. Till we hit 0, 1. Then it starts going smaller, but still positive. And then we hit negative 1, 0, so we still are at 0. We then go into the negatives. We get a little bit negative, a little bit more, until we hit all the way down to 0, negative 1, so negative 1. And then we start coming back up almost to the positives. So less negative, a little bit less negative, until you hit back at 1, 0. So 0 is the sine. So this is the unit circle for sine. Extended out, and it went all the way from 0 to 2 pi. We can connect it with a curve. There we go. This is the sine. This is the curve for y equals sine t. You could also get this same graph by filling in a chart. So t, because it's sine of t, that is just like your x value. The sine t that you get out from the point is like your y. So when t or x is 0, you get out 0. And we're going to use pi over 6. Your y value is 1/2. So we went a little bit up and halfway. Pi over 3, and all these are coming from the unit circle. Pi over 3 is root 3 over 2. Let's go up to pi over 2. You get out 1 for your sine. 2 pi over 3. From the unit circle, you get root 3 over 2. So it's coming back down. They match. So that means the next one needs to give us 1/2 out. So we are at 5 pi over 6. So you get 1/2 out. Down to pi. We need to hit 0. So this point right here is pi. It's halfway. And now we start getting out negative values. So after pi, you got 7 pi over 6. We get the negative 1/2, so it's just the opposite sign of this one. For 4 pi over 3, excuse me. We need to get out a negative root 3 over 2, and it continues until your last one is you're at the full 2 pi, and you get out 0 for your y value. We can do the same thing for the cosine. So we once again have the same unit circle. We're going to be starting at 1, 0. But remember, it goes cosine t, sine t. So we want the x value. So we're not starting at 0 anymore, we're starting at 1. Our cosine of our next value is going to be a little bit less than 1 because we're looking at the x value, the distance away from the origin. So it's not quite 1, so it's a little bit less. The next one's less than that. Once again, a little bit less. Now we're at the point 0, 1. So we have hit the x-axis. On quadrant 2, your x values are negative, so we're going below the x-axis for 3 values until we hit negative 1, 0 on the unit circle, so the x value is negative 1. Over to quadrant 3, your x values are still negative. More negative for the first one, and then it gets less. So it's kind of reflecting the green points until we hit the 3 pi over 2 point of 0, negative 1. You want the x value, so that is 0. Over to quadrant 4, you're getting more and more positive until you are back at the start of 1, 0. Now let's connect that with a curve. So our start point on our x was still 0. Our end point was still 2 pi. Let's find out what the big dip is right there from our table. So now we're looking at the cosine of t. So this sounds a little bit different, but t is being replaced by x. So the cosine of t is our y value, but it's really the x value at the point. So when t is 0, our cosine was 1. Pi over 6 from the unit circle, you get root 3 over 2. Pi over 3, it's less, it's 1/2. Pi over 2, you got 0. 2 pi over 3. We're now down into the negatives, so negative 1/2. We're on the first of the green point right there. Up next, you got 5 pi over 6. You're still in the negatives, and it's reflecting. Negative root 3 over 2. When we hit pi, we are at negative 1. After pi comes 7 pi over 6. We're starting to get a little bit less negative, to be a negative root 3 over 2. So our main dip happened at pi for our x value. And we could continue this table until we hit 2 pi, and we are back at 1. So for the general graphs of sine and cosine, so if we have y equals sine of x, it starts at 0, 0. Its max height is 1. Its minimum height will be negative 1. The circumference of the circle was 2 pi, so we just rolled it out and it followed this path, so it is 2 pi. This point right here where it crosses the x-axis, your intercept is pi. Now this could continue in either way, either direction. It doesn't just do this one curve. It continues in both directions. For your general cosine graph, y equals cosine of x, it starts at the point 0, 1, and it's going to start by going down. It will hit a minimum of your y value of negative 1, and then come back up. So we're starting at negative 1, and we're going down till we hit negative 1 and come back up. Oops, hand slipped. Until we hit our peak value, and then it's going to start coming back down. So right here it peaked, so that is your 2 pi, that is your full rotation. Its lowest point we found was at pi, and we could continue this the other direction as well.